Screen load up. Okay, here we go. Question number 1 says, what is the volume of the prism? So prisms, there's a lot of formulas here. I can even send you a reference sheet if needed, but volume of prisms is length times width times height. Okay. So, length, width, and height. You may have also seen this in class, the area of the base times the height.
Yeah.
They're equivalent. Sometimes it's easier though to just go off of the one that's length times width times height because you have those 3 dimensions. If you're going to use the second one, you have to decide, well, what is the base? Meaning, like, what is it sitting on? The base is, what it sits on, basically. So both give you the same calculations. I'm going to use the first here. It's 4 times 2 times 1.5. If you got that calculator handy, go ahead and calculate that for us, please.
Okay, I got 12.
12, perfect. Now, the units are very important here. So units of volumes are always in units cubed, meaning like if it's meters, 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 meters cubed. So they're looking for the final, the answer has to have those dimensions in it. All right, so number 2 is really similar. So let me know when you get all that down. We'll move on to number 2.
Okay, yeah.
All right, so number 2 here. What is the volume for the prism? So again, you have your choice here. Now, one of the oddities of this is this thing sort of at an angle. You can think of like a box that's sort of been crushed or pushed over. It's still length times width times height. It's the height here is the 90-degree angle that's made with the ground. If you don't like that, you could find the area of the base and still multiply it by the height. It's the same thing though. So it's 6 times 11 times 14, and that will be also in meters cubed.
Okay. That is 924.
924, perfect. Now, just look at this. It looks like it might be something you're submitting online. Not really sure. Just be careful if it's just to put units in or not, because it may not want those. So, because it looks like number 3 is a multiple choice. So, shifting that here a little bit. Okay, so volume of a cylinder. So cylinders are a lot like prisms. It is the area of the base times the height, but the base this time is a known thing. It's a circle. So sometimes students prefer the pi r squared for the area of the circle times the height. It's kind of like the first equation is like the general one that always works. And the second one is more specific to cylinders. If you're taking like SAT, ACT, you will want to know this formula, so it's worth remembering. Hardest thing here is to figure out the values, okay? R is the radius. It goes out from the center of the circle. This length right here is not the radius, it's the diameter. And you probably remember from class that you've got to cut that in half.
Yeah.
So pi 13.4 squared times 9.8. Do any of these answers look correct?
Wait, really quick.
Sure.
So I'm writing it down. Okay.
So the pi button is in the one of the I don't know what to call it, buttons there. One of the nice things about that calculator is you just enter it the way it's shown. I put everything in parentheses just for consistency.
I got 5,528.22.
Perfect. Centimeters cubed. So in a lot of ways you can say, well, this isn't all that hard. I mean, if you have the formula, which is true, if you have the formula, you know the formula, you know which one to use, it's really not that bad. I mean, you're just putting the numbers in, using the calculator.
That formula sheet that you were talking about earlier, could you send me that over?
Yes. while I'm looking for that, why don't you give this one a try, and I'll just drop it in the chat here when I find it.
Okay.
Same formula, pi r squared h. They're giving you all the values there. This one's rounded to the nearest hundredth, so just be careful on that.
Okay.
Let me see areas and volumes. Okay.
Okay, I got 628.32.
Okay, let me just check that here, just because I know you're probably only going to get correct or not on this. Yeah, that looks good. 628.32. So this first one I found that I've given to students over the years, it's not as good as I remember it being, but I'll still drop it in the chat here. What it does not do is it does not give you the like the pi r squareds. So I can also look for another one here as well. Like it just says area of the base, which isn't always all that helpful for you. But I'll look for another one here shortly. It also has surface area though, which I think is why I liked it, and lateral area, which is probably upcoming in this part of the course. Maybe it's even the next section here.
Oh, maybe.
All right, so this one says, what is the volume of the solid produced after rotating the figure around the given axis? Round your answers to nearest hundredth. So they're saying, like, imagine that this rotated around that. I don't know how visual you are. Or if you,
I'm like pretty visual.
okay,
Can like understand that that'd be like a cylinder.
it would be, yes, exactly. And I think there's even questions where they just ask you, to identify what it is.
Yeah.
So now, like, what I would still do is I would draw the final cylinder.
Mhm.
And you're getting, no grade here for artistic abilities, but it's good to sort of know. It's good to sort of know, like, well, what does it even look like? Because the 8 here is the radius. Because when this thing goes all the way around, you've got another 8 over here for the other side, the diameter. And
Mhm.
it's easy to get, mixed up with using the wrong dimensions here. So 8 squared times 8 and round to the nearest hundredth. So just be careful on that one here. Let me do that as well. Let me know when you've got an answer there.
I got 1,608.50.
Yes, good. So it's 495. That 5 rounds the 9 up to 0, 0 to, and then the 4 goes up to 5. So good, really good. Let me grab the next one here. Yes, okay. I've got another student that I'm helping that, boy, these look really familiar. And I wonder if you guys are in the same school district or something.
No, that'd be kind of funny.
Yeah. All right, so find the value for V. Okay, that's a little weird. So they're saying find the height, basically. What is the height? This is one of those working backwards problems. So previously, you were given the length, width, and height, and you just found the volume. Now you're given the volume, and you're given 2 of the dimensions, 12 and 15, and you have to find the missing dimension. They call it V, so we'll use that.
Mhm.
Couple ways to do it. You can multiply 12 times 15 and then divide. You can divide by 12 and then divide by 15. Totally up to you. This one does work out nicely, I believe. So let me go ahead and calculate that for us, please.
Would V be 2,520, or would I divide?
You're dividing. So
Oh, okay.
here's how I recommend you do this. I recommend you multiply double equal 12 times 15. So that's 180 V. And then you show division on both sides
Okay.
of the equation there.
Okay, I got V equals 15.
That sounds pretty good. So it'd be 15 yards, but you only need the 15, I believe, for this.
Mhm.
All right, so this one's slightly better, this reference sheet here, I think. Page 2 has the volume formulas that we're kind of looking for.
Mhm.
You can take a look at that if you want. Let's go to the next question. All right, find the missing dimension of the cylinder. They're giving you the volume, they're giving you the height, they are not giving you the radius. So the volume formula is pi r squared h. The volume is 1696.5, pi r squared, and then h is 15. So just putting those numbers into the formula there. So a couple ways to do this. You can divide both sides by 15 pi. Like if you go to that Desmos Scientific, you can actually put in, you can show this on the bottom, times divided by 15 pi. Now, if you're using a TI 8384, you got to be careful with putting this in the bottom there.
Mhm.
But that equals r squared. That's not our answer. That's r squared, because the radius is squared in the formula. You have to undo the square. You undo that with square root on both sides of the equation. So your
Okay.
calculator can actually take all of this. Like that's what's so nice about, you know, the calculator itself. You don't have to do it piece by piece. It's not like us, you know, where we got kind of limited memory and capability. It will do all of this at one time.
Okay.
So
One. Okay, I got 18.85
for the final answer or just the,
for R.
okay, I got a different value here. Are you using the Desmos or using a TI 80
The
384?
TI 84.
Okay, so make sure there's parentheses right here,
Oh, okay. I didn't do that.
which is, yeah, it's a common thing to misremember, because you're like, why wouldn't the calculator know? Well, calculator doesn't know what you're trying to do. So keep that in mind here, because it does work out fairly nice. It's actually a whole number.
Okay. Okay, I got 6.
Yes. Very good. All right, number 8 here says, what is the volume of the prism? Hint, figure out what type of prism it is first. What is the base? So the volume of a prism is always the area of the base times the height. And the base is the thing that it sits on.
Mhm.
Okay, now you might think that it sits on like the rectangle, but the other way to look at like what it sits on, it's the shape that, and this is, I don't want to get too technical, but it's called a cross section, is always the same. You don't need to know all that, but it's like how would you slice this thing so that the slices always look the same? And so maybe that's, you know, tough to see, but it's like if you were to slice it, it's always hard to do this in 2 dimensions. Like let me actually do it differently. That's not going to work visually. So if you were to slice this thing down here, you would get that triangle. And if you had sliced this thing up here in the same direction, you would also get a triangle. So this is a tough one. Oop, did you jump out? So jump.
Okay.
You really?
Hi.
Not sure where we left off, but I was trying to show you cross sections here and basically show you that if you slice this thing a certain way, you always get the same cross section, and the cross
Mhm.
section is the base. And that's what's maybe hard here is to see that in this problem, the cross section is this triangle
Uh-huh.
because that's what it sits on. It literally like that's the thing that would be touching like the table or the ground, and you have to find the area of this triangle.
So would it be 2 times 5 times 4?
So it's much simpler than that. It's area of the triangle is base times height divided by 2. The base now, the b now is the dimension that the triangle sits on, which is the
Mhm.
5.
Oh, okay.
And then the height here is this dimension right here, which is 1.5. They give that to you. That's nice. And then you divide it by 2. But that's only the triangle part. It's not the full volume formula. So
Okay.
I know this like because the first time you've seen one of these, it's a couple of things in a row here. The area of the triangle is 5 times 1.5 divided by 2. Okay. But the whole volume is that area of the triangle times the height. So it's the 5 times the 1.5 divided by 2 times the 4. The 4 in this problem over here is the height. So, I mean, we're gonna do more of these, but this is kind of what to expect here. Let me know what you come up with here
So
for
the
fun.
base is 3.25. And then
Yes, that's 3.75 or 3.2. Should be 3.75.
yeah.
Yes, okay, that's what I heard.
And then the final volume should be 15.
That sounds right.
Okay.
And this one is yards cubed. I don't know that it's asking for that, but like if this were a paper test, you have to show that or it'll be marked wrong.
Mhm.
Um, all right, number 9, find the volume of the hexagonal prism. The volume of a prism is always the area of the base times the height. So the base in this problem is a hexagon. And we were for a while using the formula. The area of the regular polygon was 1/2 the apothem times the perimeter. So
Mhm.
do we have those values here? Like, do we have the apothem in this problem?
Yes, it's 3.5.
Yes, thank goodness we've got that, because if we didn't, we would have to do something else. How about the perimeter? Do we have the perimeter, or can we calculate it?
We could calculate it.
Yeah, each side is 4. Hexagon has 6 sides, so the apothem is 3.5. The perimeter is 6 times 4. So all of that is the area of the base. So you do it in pieces. You find the area of the base first, and then go from there. Let me know what you come up with for this.
Okay, 42.
42. Good. So that is the area of the base. The height is, and sometimes it's like hard to find, but it's the missing. It's the one maybe you haven't used yet, which in this case is the 3. Sometimes they give you extra information, but so go ahead and calculate that for us, please.
126.
126 feet cubed. Very good. All right, number 10 here. All right, so probably the toughest of them all here. It's composite solid. Composite just means there's two solids or more that you're trying to find the individual areas of. So in this case, it's like a box on the bottom. So we got to find the volume of that. Plus, I'm going to draw this thing on the top slightly differently. It's really a cylinder, but it's like cut in half. So if you can think of like this is what a cylinder looks like. It's cut like that down the
Mhm.
middle, and like this is gone. I don't know if that's confusing or not, but it like to me this looks odd, but maybe it looks okay to you.
It looks good. I don't know.
Okay, so let's go that direction. We'll use it. We'll go the way that they have it presented there.
So the formula for that one would be like 1/2 times pi times r squared times height, right?
Exactly. And so what is the radius in that in the
It'd
cylinder?
be 2,
It is 2. So 1/2 pi 2 squared, and then what's the height, which is this dimension along here?
4.
It's
Oh
4.
wait, yeah.
Yes. So you got 4 times 4 times 4. And then you've got this other one over here on the right here with more 4s. Go ahead and calculate that. I'll do the same here. This one I can't do alone, but gotta get some technology involved here. Times.
Okay, for the half cylinder, I got 25.13.
Yep, that's correct. And this one is 64. So you can add those together.
89.13.
Yes. That's the total volume. Good.
Okay.
All right. So that's volume. I don't know what we're doing next year. 11.4.
I think it's just volume of like cones and triangles.
Yes, more volumes here. That's
Yay.
mass. Yeah. Solid. Okay. Okay. Yeah, I'm looking it over here. I'm just trying to decide if we should do 9 and 10 first. They're kind of more like the ones we've been doing, but we'll just wait, get those done. They're out density, which you probably saw in chemistry at some point. So your mom asked if I could help you with chemistry, and maybe she already told you this, but I could help, but more of the math problems, and you can always like send over. She can send over something, and I can let you know
Okay, yeah.
if it's a good fit or not, because there's a lot of chemistry that's math, but there's also a lot of it that's just things that you can look up on the internet, like, you know, things that aren't really math related, I'll say. So, all right. So the volume of each solid. So pyramids here, kind of an interesting thing. The volume is the area of the base times the height, like we've been doing over and over again, but it's
Mhm.
1/3. Now, why is it
Oh.
1/3? That's a more involved question. It's it comes out of something that's beyond the scope of this course, but it always bothered me, like, well, why is it 1/3? And you really can't answer that at this point. You can show it, like if you ever been to like a drinking thing where they give you those cone, and you're like, man, that wasn't very much water. If you fill up, you can actually fit 3 of these cones inside a cylinder, and you're like, oh, okay, well that's why it's 1/3, but still doesn't kind of make sense. So the area of the base here, though, can change. In this case, the area of the base is a rectangle.
Mhm.
Sometimes it's good to draw that if you're just to confirm that's the area of your base. The height, though, is this vertical distance here. That's the height.
Mhm.
So 3 numbers, divide by 3 at the end, or put 1/3 in the beginning.
Okay, I got 9,216.
Very good. So that would be inches cubed if it's asking for it. Volumes are always cubed. Let's actually do 3 next, because it's more like 1, and then we'll. So remember I was talking about doing problems that are all kind of the same.
Yeah.
I mean, that's where you got to be careful, because if you go to 2, two's a cone, it's not a pyramid. I don't know, like it may not matter, but this is just a strategy that I think is potentially helpful here. So the volume of the pyramid is again the 1/3 the area of the base times the height. The base this time is a pentagon, and the area of the pentagon is from the 1/2 apothem times the perimeter. If they give you this information, are they giving you the apothem? Are they giving you the perimeter? Can you calculate, one or the other?
They're giving us the apothem.
Yes. And that's 6.2. What about the perimeter?
We could do 9 times however many sides there are.
Okay, so it's a pentagon, 5 sides. So that's this AB area of the base part. And so you can get that number, and then it's 1/3 that number times the height. The height in this problem is 7. So it's just about piecing those values together. Let me go grab my calculator.
Okay. Okay, I got 139.5.
Good. And you'll keep hearing me say yards, or yard, in this case, yards squared, because it's an area. Only because that really does matter at some point. And so that's the number that comes up into the other formula here for the area of the base.
Okay, for the volume, I got 325.5.
Yes. Very good. Yards cubed.
That's cute.
All right, so we're gonna do one more prism problem, or I'm sorry, pyramid problem. Then we'll go back and do 2 and 4. So I'm gonna do 5 next. This one is slightly different. I mean, it kind of looks the same. But you start out with volume of the pyramid as 1/3 the area of the base times the height. So the base this time, though, it's a hexagon. It's got 6 sides.
Mhm.
Sometimes it's good to draw that. And do we know the apothem? Do we know the apothem? And you see right there, we don't. It's
No.
like, well, darn, like, what can we do to get that? Well, it would be really ideal if we had it. They're kind of trying really hard to show you that this triangle right here is how you find the apothem,
Mhm.
because they're giving you the hypotenuse and the height. So they're basically giving you the 3 sides of the triangle. So I'm gonna come over here and draw that.
So should
9,
we do Pythagorean theorem?
exactly.
Oh,
A
okay.
squared plus 9 squared equals 10.4 squared. Now, if A doesn't work out perfectly, round it to like 4 decimal places, because we're going to use it in another calculation. We don't want to be off by, 100th or something at the end. This one might work out nicely, though.
Okay, I got a squared equals 27.16.
Okay, so we got to keep going. Take the square root of that, please.
Okay, 5.2115.
Yes. And that's why I mentioned, like, it doesn't work out nice, so just round it out, go out further with it.
Mhm.
And so this is where you gotta be careful. It's like, okay, well, why was I even finding that? Because we want the area of the base. The base is a hexagon. We want the apothem to find the area of the base. So to do that, the area of this thing is 1/2 the apothem, 5.2115, times the perimeter. Do we know the perimeter of this hexagon?
It's 6 times 6.
6 times 6, good. So that will give you the area of the base, 1/2.
Okay.
Let me know what you come up with for that.
Okay, I got 93.07.
807. So maybe go out again 4 decimal places because you're going to reuse that value. I'm sorry, 8075. Okay. And that's the area of your base. Okay.
Mhm.
So now we're ready to actually find the volume of the pyramid if we know the height. Do we know the height of the pyramid?
9.
It is 9. Yeah. So you're almost there. Kind of a 3-step calculation. 1/3, 93.805 times 9. And give me that to 2 decimal places, please.
Oops. Okay. I got 281.42.
Good. Okay. Lot in that. I mean, that's a full problem. That's really, a lot of work to do, just get a final number, but that's the nature of these things. So we'll go back to 2, we'll do some cones. The cone is the party hat. It's that cup they give you at the water dispenser sometimes. It doesn't have very much water in it. So volume of a cone, it's very similar to the pyramid. It's 1/3 the area of the base times the height. And you might say, well, that's exactly the same as the pyramid. And I would say you're right. But the base this time is a circle, not a square, pentagon, hexagon, whatever. So this is where sometimes you see students go to pi r squared because that's the area of the circle times h. Like they just remember that. Now, does this also look familiar to a cylinder?
Yes.
And it should, because they're very much related. It's just got the 1/3 there. So you've only got to find the radius and the height to do this problem here. So it's 1/3 pi 9 squared because the radius is 9 and the height is 18. And these are rounded answers, or is there like a whole number? Because sometimes you just leave it in terms of pi.
I think we just rounded.
Okay. Very good. So let's go ahead and calculate that for me, please.
Okay, I got 1,526.81.
Yeah, so if you don't, I'm just going to put this in here in case there's a difference when you get this graded, but it's 486 pi, and then when you do the final calculation in the calculator, just like you said, like that, and then it's miles cubed because it's a volume. All right, so let me grab the next one here, number 4, which looks really similar at first glance, but they're actually not giving you the height this time. So let me snip that in. It's really nice when they just give you all the numbers. This time though, volume of the cone is 1/3 pi r squared h. You have the radius, that's good, but this number right here is not the height. It's actually what's called the slant height, but that's not useful. You actually want the height here. So this is a right triangle. How do you find the height in the right triangle?
Pythagorean theorem.
Yes. So you got h squared plus 8 squared equals 10 squared. This one does work out nicely. So go ahead and calculate that for us, please.
Oh, it's 6.
It is 6. Very good. So the height is 6, and you put that into your formula here. We got 8 squared times 6.
Okay,
Let
I
me know.
got 402.12.
Yes. Feet cubed. Good. Okay. All right, let's grab the next one here. Okay, so 6 is going back to pyramids. So it says find the height of the pyramid. So we know the volume is 1/3 the area of the base times the height. The area of the base is this rectangle, 8 times 12, but we do not know the height. I mean, that's what it's asking for. It's asking for the height. The volume is given. So that number goes in for V, 1/3 the area of the base, which is 8 times 12 times the height.
Okay.
Now, what I would recommend doing is multiplying this stuff over here on the right.
Okay. So I got 32. And then we would divide that from 224, right?
Yes, but wait a second here. What did you get on the right here?
32.
Okay, 32. Oh, sorry, I heard something different. But yes, so you're going to divide both sides by 32.
Okay, I got the height is 7.
The height is 7. Good. So sometimes it works out nicely. It's always good to do the calculations twice. This one you can also work backwards. Like once you know the height, and this would like apply to a test or something, is you would then just start, like, assume you don't know the volume. It's like, all right, 1/3 8 times 12 times 7. Does that give me 224? Yes.
Okay.
All right, so new question here. Number 8. Sorry, 7. The next two are composite problems, and there's two types of composite problems. The one we did like in the previous homework assignment worksheet is where you add the two together, and this is where you're gonna sum them or add them because they're contributing together. Okay, so this first one is a cylinder. Next one is the cone, the party hat. So you want to find the volume of each. So you can maybe identify what it is: cylinder, cone, and then write the formulas for each. So in this one, it's pi r squared h. Let me do it up here. And this one is 1/3 pi r squared h. So notice the similarities. Basically the same except for the 1/3, and that really it makes it easier to remember if you say, okay, this cone is like a cylinder. That could help. What is the radius of this cylinder here?
Oh, it's 6.
It is 6. Yeah. So it's
And
pi.
that'd be the radius for the cone as well.
Exactly. Yeah. So your calculator can do all this together. If you don't want to do it all together, that's fine. Just be careful there with rounding and stuff in between answers there. But let me go ahead and grab some of these numbers here for you. All right, so that's the first one. right, so let me know when you got those numbers, we can check them here.
Okay, for the cylinder, I got 2,261.94. I mean 95.
Good.
And I'm still doing the cone one right
Okay.
now. Okay, and then for the cone, I got 565.49.
So the height of the cone is 15. I got a slightly different number. Let me check mine here. I made the mistake. Okay. Yes, that is correct. 565.49. And then you add the two together.
Okay, I got 2,827.4337.
So 443, we'll say.
Yeah.
Okay. So if you put the whole thing in your calculator at one time, okay, you will get just the tiniest, little difference in your answer here. And this is where as a student, I think it's very frustrating. You're like, wait, I mean, why does that even matter? When we round, we got to be very careful here that it actually gives us the same thing. This one actually does. But if you use these rounded results, you actually get 44. So, but this is correct. This is totally totally good there.
Okay.
All right, so we're really kind of out of time here today. I'll just quickly tell you what to do on 8, or we can pick up tomorrow on that as well. But the volume of the solid here, you have to take the volume of the prism and subtract the volume of the pyramid. And then for 9 and 10 here, you will want to use a density calculation here. So you want to use that density is mass divided by volume. But I think we got to listen tomorrow, but I'm happy to pick up there tomorrow. But we do have to stop here for today.
Awesome.
So let me go ahead and stop the recording here.